All right, precalculus here is section 4.7. It's on inequalities. Okay, so look what we got going on here. We have a polynomial raised to the x to the 1 and then x squared. This would be x to the third. It's a polynomial inequality. So look, I'm taking y equals x plus 3 times x minus 1 squared. Now, you don't have to write this down if you don't want, but I'm going to actually multiply this out just so you see what we're really doing here. Okay, y equals, that's going to be x squared minus an x plus 3x is plus 2x, and then minus 3. It's times x minus 1. And then if I multiply this out, I'm going to get x to the third plus 2x squared minus 3x, and then it's minus all these things, so minus x squared minus 2x and plus 3. Okay, so I really have y equals x to the third plus x squared minus 5x plus 3 that I'm dealing with. It's a swooshy. But I'm only looking for where it's greater than or equal to 0. Okay, here's how you can solve an inequality for polynomials by graphing. Graph it, look at it, and then write the answer as x intervals. Okay, it's a swooshy, it swooshes up, and I already know the zeros. 1, 2, 3, there's one at negative 3, and there's one at positive 1, and this has a multiplicity of 2, so that's going to bounce back. So this graph looks like that. See what I mean? Now, where is it greater than or equal to 0? Isn't it greater than or equal to 0 here, and here, and here, right? So it starts at negative 3. It's greater than or equal to 0, so that actually counts. I'm going to put a bracket around it. And then it goes to 1, and when it gets to 1, it's actually equal to 0, and then on the other side it's positive, so I'm just going to say this goes all the way to positive infinity. Graph it, see it, write it. Okay, now I'm going to solve a polynomial inequality algebraically. I'm going to do this without graphing it. It's a lot easier to graph it, I think, but doesn't nobody, that's great English right there. Doesn't nobody want to actually use synthetic division and solve and stuff. So here's what you do. Find all the real zeros. Divide the x-axis number line into intervals separated by these zeros. Check an x value for each interval. Okay, now I don't have to use, doesn't nobody have to use synthetic division here. I can just factor by grouping. So take out an x squared and you get x plus 2. Take out a minus 4 and you get x plus 2, and it's less than 0. Okay, these have the same thing, so I can use the distributive property to factor out this x plus 2, and I get x plus 2 times x squared minus 4 is less than 0. X squared minus 4 factors, I have x plus 2 times x plus 2, and x minus 2, it's less than 0. Now I got a multiplicity of 2 here. I have zeros at x equals negative 2 and x equals 2. This one has a multiplicity of 2. Okay, so I found all the zeros. I'm going to divide the x-axis into these intervals. I'm going to check an x value in each interval. Okay, so let's just make a little number line here. And I'm going to put a negative 2 and a positive 2 where they would go. And now let's check x's in each one of these 3 spots and see which ones are in fact less than 0. So put in a negative 3. If I put a negative 3 in, don't put it in the complicated one, put it in the simple one. Negative 3 plus 2 is negative 1. Negative 3 times plus 2 is another negative 1. And negative 3 minus 2 is negative 5. Negative and negative and negative. Is that going to be less than 0? Yes, that's going to be negative. Check. So this part right here is definitely negative. Okay, then I'm going to check 0. Put a 0 and see what happens. 0 plus 2 is 2, 0 plus 2 is 2, and 0 minus 2 is negative 2. Is that less than 0? Yes. We've got 2 places. So that's negative as well. And then go over here and try a 3. When I put 3 in, 3 plus 2 is 5. 3 plus 2 is 5. And 3 minus 2 is 1. Is that less than 0? No, it's not. So my answer is going to be from negative 3 up until, not negative 3, sorry. My answer is going to be from negative infinity up until 2. Now we got to think about the the less than or equal to and the brackets and the parentheses a little bit. At -2, you actually have a 0. It's equal to 0. So it can't be less than 0 if it's equal to 0. Okay, so I'm going to start at -infinity. I'm going to go up to -2, but I'm not going to put brackets. I'm going to put parentheses. Then I'm going to go with a union, and we'll go from -2 up to +2. That covers all of my negatives, but this one is out. Okay, I couldn't actually say that's less than 0 because it's not. It's actually equal to 0. But everything else, -infinity up to -2, and -2 to 2, those would all be negative. All right, next page.